So the last two pieces of this lesson that we still need to do then are inverse functions, which I know you guys have talked about before in 3A, and review how to do those. And then we're also going to talk about how to graph logs and what those look like as well. Okay, so for inverses, the idea behind an inverse, both algebraically and graphically, is that x and y are switched. So if you have one graph with, example would be like if you had a 2, 4, my inverse graph should have the point 4, 2. All right? So to do that, we only have to switch x and y. So let's do that in our equation here. I'm going to write x equals 8 to the y. Which really is the inverse, but we don't typically write equations like that. Typically, we have an equation where y is by itself. Okay? So I'm going to need to solve for y, and y is in my exponent right now. And when I need to solve for my exponent, I need to rewrite it. So I'm going to change the form that it's in. Okay, let's over to the side here, let's write down an example of changing form. I'm going to give you something in exponential notation. 5 squared equals 25. You guys change it to logarithmic. And write this down on your slide because it's going to help you out. So in logarithmic notation, this would be log base 5, right? Because same base in your log is in your power. So log base 5 of 25 equals 2. If we can remember a simple form like that, we can go back and forth pretty easily. We just have to match up our parts. For me, it's easier if I have something written in exponential form if it looks like this. And so I'm going to switch my order. I'm going to say 8 to the y equals x. If I have it written like that, it's easier for me to convert it. Maybe it doesn't matter for you. It's up to you. But I would need you guys now to rewrite that in logarithmic form. Okay, so following that example, in logarithmic form, it would be log base 8, same base as my power, of x equals y. And once we've flipped x and y and we've solved for y, we're done. This is our answer. Okay, so what did we just do? Well, it's helpful if we look at this graphically, and I'm not going to ask you guys to do this right now. Next lesson, we'll get more into how to plug this into your calculator. But our first equation that we had was 8 to the y, or 8 to the x equals y. So I'm going to graph that. That's just a normal exponential. And again, you don't have to do this. The other one, I can plug this in as log of x divided by log of 8. And I'm not going to get into right now why I can do that. We'll, again, do that next lesson. I also am graphing here y equals x. Y equals x is the reflection line for inverses. Okay, so when we graph this, you should be able to see that we have two different graphs that are reflections of each other over that y equals x line. So here's y equals x. Here was the exponential. And here was the log. Okay? Do they look like the reflection? Yeah. Another thing that you can do as well to know that those are reflections is if I go to the table and I find a point on the table like 1, 8 for my exponential graph, I should have the point 8, 1 for my logarithmic graph, and here it is 8, 1. Okay, so if they really are inverses, that should be true. Who has questions? Yes. I'll show you that later. Okay. All right, so next one. We're again going to find the inverse. Okay, before I even switch the x and the y, we're going to want to always have a base for our log. So ln is what again? Log base e. So let's do that right away. Y equals log base e of x minus 4. Okay, so then you guys go ahead and switch your x and your y. So we're not done, and be careful on this because every single time I teach this, we get to the quiz and kids leave it like that. Well, you've done a fourth of the problem. Okay? The next step is that we have to solve for y. We have to get y by itself. Now, before we get too excited about getting y by itself, I really need you to think order of operations. And this probably seems like a long time ago that you learned order of operations, but when we get confusing equations, if we go back to the basics, it makes it pretty easy. So order of operations, and I'm solving for y, trying to get y by itself, and I have to go backwards. Then solving. Okay, so which pieces do we have here? Well, if I want to get y by itself, I have a minus 4 here, which normally we would think that's subtraction, but really it's inside the parentheses. So I have to count that as p for parentheses. And then where does the log come in? I need to get rid of that. Well, log is really just another way to write an exponential. So I'm going to call that an exponent. Okay, so I need to first, if I'm solving for y, get rid of my exponent, get rid of my log. So we need to convert from logarithmic to exponential. So let's write that little thing over to the side again. We had 5 squared equals 25. It's the same as log base 5 of 25 equals 2. You guys convert. So let's see if we know what we're doing. We want to go from logarithmic form to exponential form so we can get on the inside of that, so we can get that y out of there. So same base in my log is base in my power. So I have e to the what? E to the x. E to the x equals y minus 4. Now, we really don't need those parentheses there anymore because we just got rid of that log part, and that's the reason that those were there to begin with. So I'm going to get rid of those. So our last step then is going to be to solve for y to move that 4 over. How do I move it over? Just by adding, yep. And so it's going to be e to the x plus 4 equals y. Now these we can put both of these in our calculator. So grab your calculator and go to your y equals. And we have ln of x minus 4. That's the first one. You guys plug that in. And then e to the x plus 4. And then also graph that third equation, the y equals x line. It's a little easier to see then if it really is a reflection. Go ahead and graph those. Now your calculator cuts off anything that it thinks is getting a little too vertical, because vertical lines are undefined. This really isn't a vertical line, it just stops showing it. What's it called if it's getting really close to a vertical line? What would that vertical line be called? What was the horizontal line called? in the asymptote. Yeah, so this one over here, this is my log. Logs have a vertical asymptote where exponentials have a horizontal asymptote. Okay, and that's because your x and your y are switching. Go to your table and find at least one set of points where the x and the y flip-flop from one to the other. For this one, there's not as many of those points because it's an e, because of the decimal. But I have 5, 0 here. I should have 0, 5 as well. So there's one. Questions on that last one? Okay, let's try this next one. So first of all, rewrite it so that it's a log with a base. And then switch your x and your y. You might want to add another page in as well if you feel like you're going to run out of space. Are we all here? Yes? Okay, so again, before you get into solving for y, let's think this through, because this gets confusing, especially when we have that addition and subtraction thrown in there. Trying to get y by itself, right? So I have a log, and we're calling a log an exponent, or something to do with exponential at least. I have minus 4, which is inside my parentheses. And then I have a plus 2 on the outside of the parentheses, so that's addition. What should I move first? The addition. Okay, so move the 2 over. Then I'm going to move the exponent, which basically means I need to get rid of the log. Rewrite it in the other form. Rewrite it in exponential notation. Okay, so this looks a little tricky, but if you can remember every single time that the base in your log is the base in your power, I have e to the x minus 2, that whole thing is going to be your exponent, equals y minus 4. And then finally you can move the 4 over. Now the 4 is not going to be a part of the exponent. It's going to be added onto the end. So e to the x minus 2 and then plus 4 equals y. Okay, we're going to let all that sink in. And we're going to do the last part. We're going to do the graphing piece. Okay? So how do the graphs compare? Well, we already talked about this a little bit. I already showed you an exponential and a log, just like this blue and the red one up here, and how the inverses are reflections of each other over the y equals x line. And we also already talked about how the exponential has a horizontal asymptote, right? And the log has a vertical asymptote. And that's because of your x and your y flip-flopping places. All right, so we'll take a look at what each of these graphs should look like. So we're still getting used to this whole idea of logs, and it still looks a little foreign to us, kind of like a foreign language, right? And so if we can convert this to exponential, something that we're comfortable with, it's going to be a lot easier to graph. So I want you to forget for a second. Forget that you ever switched your x and your y, because that's only in inverses. Okay, in this one we're not graphing the inverse, we're graphing this log base 3 of x. So don't switch your x and your y, just convert from this logarithmic form to exponential. You guys write it down. So again, we're not switching x and y, right? We're just converting. So same base in my log is base in my power. So I have 3 to the y equals x. Now that looks funny, right? Because x and y aren't supposed to be there. But that's the equivalent form to our log. So instead of picking x's like we normally do, pick your y values. So you can use whatever 3 y values you want, -1, 0, 1, 1, 2, 3, 0, 1, 2, however you want to do it. You put in y values and figure out what x should be. Now, before we connect these points together, what kind of asymptote should we have again for a log? Vertical. So draw that in. And then connect your points. Okay, now take it a step further and think domain and range. So we said x and y flip-flop places, basically, from logs to exponentials. So instead of our domain being all reals, instead of our x's being all reals, our range should be all reals. Which means that we could have picked any value that we wanted to put in for that exponent. You can put negatives, you can put positives, you can put 0 in as the exponent. But what about the numbers we got out? What about the x values? Those are all greater than 0. Yep, all positives. So x is greater than 0 is going to be our domain. Okay, questions? All right, let's look at the next one then. So using the same idea from exponentials, let's take a trickier log function and make it easy. Let's get rid of the plus 3 and get rid of the plus 1 and just graph log base 2 of x. Okay, so again, you change it to exponential form, pick some y values, and then graph it. And then let's think about the shift. So what does the plus 3 do? What does the plus 1 do? Well, if a number's inside a set of parentheses, it moves horizontally. So which way do you think this one goes? The left. Horizontally is always opposite of what we would normally think. That one's going to be left 3. And then the 1 on the outside of the parentheses is going to move vertically up 1. So shift your points. What else is going to move along with our points? The asymptote. Okay, now just like the quiz, we need to list what these points are, right? So make sure you make a table somewhere or you put the coordinates down, and I'm talking the red graph, not the blue graph. The red one is the original equation. Okay, lastly, you guys, before we plug in domain and range, let's show off our log skills right now. And let's check a point. Okay, I'm going to pick this one right here. So let's plug 1 in for x and 3 in for y. And we're checking to see if this is really true. Did we really shift the right way? Did we really have the right original point? So I'm going to simplify over here, log base 2 of 4. Let's do that part. Log base 2 of 4 means that you have to figure out 2 to what power equals 4. 2 to the second equals 4. So this whole thing in the box equals 2. Plus 1 equals 3. Okay, so we've checked that. And you can do that for each of those points to make sure that you've gone the right direction. Lastly, domain and range. Please write down domain and range. So again, our range is going to be all reals. Our domain is going to be, nope, x has to be greater than -3, or that asymptote right there.